Good evening to all. Is the audio clear? And video too? Thank you. So, for the previous session, any queries in solving the higher order equations if the right side function is e power ax to anyone? Say, is that clear? As per the previous session is concerned. Yes or no? Okay. Then in today's session, we are going to discuss the methods. Whenever we take the higher order equation of the form f of d into y equal to q, if the right side part contains the functions sine or cos, that is one model. If right side function q is of the form x power n, that is one, and the other one e power ax into some function. So we are going to discuss about these three models in today's session first. Okay? Is the module clear? Fine. Now, let us take an example first. So while discussing with the example, I am going to do the problem. So let us take the problem that d square minus 3d plus 2 into y equal to cos 3x. So I request you to find the yc for the given problem. You please do it. So we are discussing about the first model, that whenever sine or cos function is presented in place of q, how to evaluate that? Thank you. So if you calculate the roots, m equals to 1 comma 2, so the complementary function yc is c1 e power x plus c2 e power 2x. Coming to yp, as the formula is given by 1 by f of d into q is equals to 1 by d square minus 3d plus 2 into cos 3x. So whenever cos or sine functions are given, obviously here we should have a number 3, 2, 1, etc., etc. The thing we have to do is you have to replace d square with minus the number whole square. So I am going to make it as 1 by minus 9 minus 3d plus 2 into cos 3x. Is it clear now what I have done? See? Right. Now if you simplify that, it is nothing but minus 1 by 3d plus 7 into cos 3x. So you have to rationalize again to get d square in the denominator. So if you rationalize that, minus 3d minus 7 by 9d square minus 49 into cos 3x. Accepted? After rationalizing. Again, d square will be replaced by minus number whole square. So it will be minus of 3d minus 7 by minus 9 nines 81 minus 49 cos 3x. So minus gets cancelled, 3d minus 7 by 130 into cos 3x. Please check. Now, since d stands for differentiation, you are applying the numerator term to the function cos 3x. So this is equal to 3 into differentiation of cos 3x is minus 3 sin 3x minus 7 cos 3x by 130. So that is the final solution. You can simplify further. So what is the procedure when sin or cos are given? You have to replace d square with minus the number whole square till d remains in the denominator. So you have to rationalize that. Again, in place of denominator, d square is replaced with minus number whole square. So finally, applying numerator to the function, you will get the particular solution value yp. So I am simply concentrating on the procedure, how to work out the method, right? I am not discussing about the theory. Is it clear to all? So the general solution is given by y is equal to yc plus yp. So the complementary function value and particular solution value will be written together, yc plus yp. That is the final solution. So please take a note of this, then I will go for the other model in the same module. After noting, please inform. Right. Practice questions you are asking. Topic wise marks distribution. So in every question paper, you will have compulsory 2 questions will be asked on higher order differential equations, what we are doing now. So definitely the minimum weightage will be 30 marks from this session, what we are discussing. And later on, I will give the topic based distribution of marks as a sheet in Telegram. I will upload it separately. Yes, for the whole syllabi. So I will discuss with Venkana sir again. So what will be the probability for 2018 and 2019 mains for topic based distribution of it? Right. Now take the problem. I will say that d square plus 4 into y equal to cos 2x. Please take a note of that. So find the yc also. I discussed the part of yp. Yeah. So m value, if you consider, it will come as plus or minus 2i. So yc is given by c1 cos 2x plus c2 sin 2x. So all of you agree? Right. Now, if you consider yp, now if you replace d square with minus the number whole square, here the number is 2. If you put the same thing here, it will become minus 4 plus 4. So the denominator gets undefined. So while doing problems, such situation will arise. For this, I am giving the formula directly. Please understand, I am not giving the theory. So the formula here is, for such type of problems, whenever the denominator gets undefined, so please note down the formula. Please note down that. Okay? The formula. So, using the formula here, our solution is x by 2 into 2 sine 2x. So, x by 4 sine 2x is the particular solution value. Then we write the general solution y equal to yc plus yp. Fine. Now, sometimes what happens, in the denominator, you may have multiple factors. For example, d square plus a square, whole cube, whole power 4. Such type of situation will arise in the denominator part while calculating yp. For that, we are going to apply the formula. So please take a note of it. X power r by r factorial cos of ax plus pi r by 2. Similarly, for the second one, so please take a note of that. So this formula is useful whenever the denominator contains d square plus a square whole square. For example, if the denominator is of the form so which comes under this category accepted? D square plus 2 square whole cube. So here a is equal to 2, r is equal to 3. So you are going to apply this formula here. Fine. How we are going to apply the formula? Any other queries? And in majority of the problems, we are going to make use of the previous formula only. So multiple roots formula, this type of thing will be asked very rare. Always we are going to make use of the previous formula, what we have learned. Okay. So let me take one more problem on this model, which gives you a overall idea how to do it. Right? Shall I continue? I just want to take two problems which gives a good idea. Not two, obviously I will say three problems I am going to take. So d square plus 9 into y equal to cos cube x. So please go with yc. After doing, please inform. I discuss with yp. Right. So plus or minus 3a. Is it necessary to write the yc? C1 cos 3x plus C2 sin 3x. Right. However, I write. Now to determine yp, the method which is described earlier is for cos x and sin x only, not for cos square, cos cube, etc., sin square, sin cube, etc. So when the power is only 1, we are going to make use of the previous methodology. So whenever the power is more, you have to convert it into linear power. How to? Just applying the trigonometric formula. So we have the formula that cos 3x is equal to 4 cos cube x minus 3 cos x. Accepted? Right. So using this, you will have the cos cube x formula. Let us apply the thing here. It is equals to 1 by 4 into 1 by d square plus 9 cos 3x plus 3 cos x. Now, this denominator belongs to both the functions, so apply individually. So 1 by 4 into 1 by d square plus 9 cos 3x plus 3 into 1 by d square plus 9 cos x, which gives, now here if you replace d square with minus b square, the denominator gets undefined. So you are going to apply the formula there. So by applying the formula, you will have x by 2 into 3 sin 3x. Here you can replace d square with minus b square. The value will exist. So 1 by minus 1 plus 9 into cos x. So this is yp value. You can simplify it, no problem. And general solution is y is equal to yc plus yp. Okay. Yeah, I forgot 3. Thank you. Is it fine now? Right. So in the middle, I just want to do like that because whether you're actually following me or not, I have a little doubt. So please don't misunderstand me. So if this model is clear, I go with the other one in the same thing. Sin or cos functions are given whenever. Shall I take? Thank you. So take the problem. D cube plus 1 of y equal to cos 2x. So please find yc, then inform. Fine. So it is nothing but m cube plus 1 cube equal to 0, a cube plus b cube formula. So m value will come as minus 1 and 1 plus or minus root 3i by 2. Accepted all? Right. Now, are you agreeing with the roots what I have written? Say. Right. So the yc value is given by e1 e power minus x plus e power x by 2 into c2 cos root 3 by 2x plus c3 sin root 3 by 2x. This is the value of yc. Now coming to yp, one by d cube plus 1 into cos 2x. So here the function has power 1. So you can apply the methodology. To apply that, we write d cube as d into d square plus 1 cos 2x. Now, this d square will be replaced by minus d square as usual. So 1 by minus 4d plus 1 into cos 2x. Now the remaining thing is common. You are going to rationalize to get d square in the denominator. So this will be 1 plus 4d by 1 minus 16d square into cos 2x. Now we replace d square with minus b square. We apply the numerator 1 plus 4d to the function cos 2x and we evaluate the answer. Fine. So can you do it on your own? So please go ahead with it. Yeah. So 1 by 65 into minus 8 sin 2x plus cos 2x as our friend's concerned. So 1 by 65 of minus 8 sin 2x plus cos 2x. So if everyone has done with it, then I go to the next model of this. Is the screen hanged? Let me say. Is it hanged? Okay, right. Actually, I am completely leaving the board for you so that whenever a person has a doubt, they will take a note of it or they will take a screenshot of it. That's why I am totally out of the board. I don't want to focus to the screen. So are you finished with it? Thank you. So take the model that d square minus 4d plus 3 of y is equal to sin 3x into cos 2x. So I will describe the procedure and you are going to simplify the solution at the end. I will write the solution at the last. Fine. So as we have given that roots are 1 comma 3. So yc is equal to c1 e power x plus c2 e power 3x. Please check it and confirm, all of you. Now to determine yp, this is 1 by d square minus 4d plus 3 into sin 3x into cos 2x. So far we have done 3 varieties. First one, power is single, d square is replaced with minus b square. Second, whenever higher power is there, we apply sin 2x cos 2x, sin 3x cos 3x formula to reduce. Another one, if the denominator gets undefined, we have the specific formula. Similarly, the fourth module is, or fourth variety is, whenever the function is given in the product, we are going to apply the trigonometric identities again here. So I think you will know the four identities that we'll simply write like this. I think you have known these formulae. Accepted? Please correct me if I write wrong anything there. Yes, the transformation formulae. Do you accept the formulae I have written? So, since here the sine coefficient is big, cos coefficient is small, you are going to pick up the first formula that sin A plus sin B is equal to 2 sin A plus B by 2 cos A minus B by 2. So here you are just taking two numbers that on adding and making it half, we should get sin 3x. Taking the difference and making it half, you should get 2x. So sin 5x plus sin x, all of you agree for that? Say, using that formula. So I am going to write it as so 5 plus 1, 6, 6 by 2 is nothing but 3x. 5 minus 1, 4, 4 by 2 is nothing but 2. Accepted all? So since the product is split in the form of sum, we are applying this thing individually to each of it, and we are going to apply the previous method as it is. What it is? D square is replaced with minus B square, rationalize, do the thing as usual. Fine. Shall I continue then? Yes or no? So just I am going to split it separately and I will calculate one value for you. Remaining you can do, and I will give the final answer for it. So just consider the part that 1 by d square minus 4d plus 3 into sin 5x. If you replace this 1 by minus 25 minus 4d plus 3 into sin 5x. So 1 by minus, you can take 4d plus 28 sin 5x. You can common 4 also here. Minus 1 by 4 into 1 by d plus 7 sin 5x. To rationalize. Then you have 1 by minus 4. So minus 25 minus 49. And you are going to apply the numerator for this and simplify the denominator, multiplying the numbers. So in order to save the space, so I have omitted 1 by 2 here, isn't it? I didn't consider 1 by 2 here. I just have taken only this and sin 5x. Accepted. Yeah, that is 22, right? Then you have to take 2 here. It will be 2d plus 11 2d minus 11. Accepted now? Say. Here also you have the same thing, 2d plus 11. So the only thing to remember here is, whenever two functions are given in the product, sine, cos, sine, cos, cos, you are going to apply the transformations there, and we will evaluate the each term individually as per the previous method concerned. Accepted? So do you agree with the part written there? Any more doubts? So I will write the final answer for the whole thing. So you check on that. The final answer is this is for YP. Please check. After evaluating the two things, so general solution is given by y is equal to yc plus yp. You can simplify that later. That is up to you. So after writing yc plus yp, whether to simplify the answer or not, it is left for you. The only thing is, you have to mention the formula that y is equal to yc plus yp and substitute the terms there. That is enough. Simplification is up to you. Okay? So these are the four varieties discussed under a category of sine or cos functions are given on the right hand side for non-homogeneous equations. Any doubt with regard to the methodology so far discussed for sine or cos functions? Please tell. Yes or no? Right. Then I go with the next method. So please understand one thing, that if I have given a problem that 1 d square plus 1 into y is equal to e power minus 3x plus cos x. Now what happens? While calculating yp, you are going to apply the two functions here. So apply the methodology of each function individually to the denominator. So for this, we will apply the methodology of e power ax, which is studied in the previous class. For this, we apply the methodology of sine or cos, which we have learned now. Okay? So I am not taking the problems which contain multiple functions, which are nothing but combinations of the previous models. I am leaving them for you as a practice. So I am just concentrating to give the methodology description and evaluation of the problem. So later I will give you a bulk exercise as a practice so that you can have it with a lot of combinations. Okay? Is it clear now? Fine. Suppose in the right hand side, if Q is of the form x power k or x power n. Now, what is the procedure to evaluate the particular solution Yp? So for this, Yp is given by, let us take a small example. So take that 1 by d square plus 1 of x cube. Now, always we write the denominator as the form of 1 plus something. Now what happens? This something part will be taken as x. So we have the formula that 1 minus x whole power minus 1 equal to 1 plus x square plus so on. 1 plus x whole power minus 1 is equal to 1 minus x plus x square minus x cube so on. 1 minus x whole power minus 2 is equal to 1 plus 2x plus 3x square plus 4x cube so on. These expansions are known to us earlier, right? I think you have known these expansions. Otherwise, please take a note of them. So, by taking the terms common in the denominator, we represent the denominator in such a way that 1 plus something will exist in the denominator. So, this will is nothing but 1 plus something whole power minus 1. So, it is coming like 1 plus x whole power minus 1 or 1 minus x whole power minus 1 like that. So, we are going to make use of one of these expansions for this coefficient, and by multiplying each term on the right hand side, we will find the particular solution. Okay? Is the approach clear now? How to evaluate that? Any more questions? To anyone? If that is clear, let us take a problem. So by taking the problem, can I explain? One after the other, right? Have you known these expansions? Otherwise, please take a note of it. So, fine. So I will take so many examples as you want until you get the 1 plus x whole power minus 2, the same thing, 1 minus 2x plus 3x square minus 4x cube so on. So whenever plus is there, symbols will come alternatively. Whenever minus is there, all the values, all the symbols are positive. So take that. So I am neglecting YC part. I feel that you are going to solve it. Okay? So I am concentrating on YP now. Shall I take? Fine. So Yp is equal to 1 by d square minus 4x cube. Our concentration is to represent the denominator as 1 plus something or 1 minus something like that. So to have that, if you command minus 4, it will come like this. Am I correct in writing the part? All of you, right? So it is nothing but minus 1 by 4 into 1 minus d square by 4 whole power minus 1 of x cube. Now it is coming like 1 minus x whole power minus 1 of some function. Now expand it. I will write the expansion again. 1 plus x square plus so on. So applying this, minus 1 by 4 into 1 plus x means d square by 4. X square means d power 4 by 16 plus so on of x cube. Accepted? Any queries in writing this expansion? If any doubts, I will repeat again. To confirm, then I move further. Right. Now what happens? Please understand that D stands for differentiation. So what happens? If you differentiate a function more than its power, it will become 0. Because we have d cube of x cube, if you consider it is a constant. If you consider d power 4 of x cube, it is 0. Accepted? So, since the expansion is containing infinite terms, so we will consider the terms which will be equal to the power only. The remaining terms will be neglected because while applying them, you are getting 0. So this is nothing but minus 1 by 4 of 1 plus d square by 4 of x cube. Now you apply that. Is equal to minus 1 by 4 of x cube plus 1 by 4 into d square stands for double differentiation. So if you differentiate x cube for one time, it is 3x square. If you differentiate for the second time, it is 6x. So 6x by 4. Accepted? You can simplify the terms again by multiplying with minus 1 by 4. So that is the particular solution value. Then we will write general solution y is equal to yc plus yp as usual. Okay? Is the approach clear to all now? Any doubts? Then on this model, I am going to take one more thing which gives a comprehensive idea on the whole. Shall I erase this? Shall I? Shall I continue now? Okay. So take the problem that d cube plus 3d square plus 2d of y is equals to x square. So please take a note of that. So you calculate yc on your own, then I discuss yp. So after finding in yc, you just inform, I proceed with yp. Just give me the roots of it, that is enough. The values of m. right? 0, -1, -2. So C1 e power 0x plus C2 e power minus x plus C3 e power minus 2x is Yc value. Now coming for Yp, it is 1 by dq plus 3d square plus 2d of x square. So first of all, take d as common. Then you have 1 by d, 1 by d square plus 3d plus 2 of x square. Why I took d as common? Because in the denominator, I should have the thing that 1 plus or 1 minus something. So that the constant must be free from the differential d. So that I took d as common first. Now 1 by d into 1 by, taking 2 as common here, 1 plus d square plus 3d by 2 of x square. Accepted? Then the remaining portion is as usual, 1 by 2d into 1 plus d square plus 3d by 2 whole power minus 1 of x square. Now it is of the form 1 plus x whole power minus 1. Let us apply the expansion here. So 1 by 2d of 1 minus x plus x square means d power 4 plus 9d square plus 6d by 4 of x square. So I have neglected the remaining terms because they will contain more power than 2. Accepted? So since 1 by d is there, here we have two things to simplify the expression or expansion. First thing is apply the whole thing with x square. Later, since 1 by d is presented, 1 by d stands for integration, you do the integration. That is one way. Usually, while doing in that model, obviously you will get a mistake in getting the constant term. So the general standard thing is, first you multiply all these values with 1 by d, so that this integration part gets simplified. Later on you apply x square. So what I am doing now, it is 1 by 2 into 1 by d minus d plus 3 by 2, then plus d cube plus 9d plus 6 by 4 of x square. Now you are going to simplify each and everything. 1 by d stands for integration. The numerator is nothing but differentiation. You can do it on your own. Accepted? Since d cube is there here, this value gives 0. So automatically you can neglect this. So 9d plus 6 by 4 of x square, you just consider. Any more queries here? So did I do any mistake there? You have to correct me. Yeah. So if I apply the whole square formula here, a square plus b square plus 2ab, it will be 6d cube. Accepted? Right. So the same thing will come, it must be 6d square. So this minus commonly belong to the both things, right? Isn't it? Fine. So the fundamental thing we have to remember here is, on applying the expansion, while multiplying, we should check each and every power of d, whether it is written correctly or not. then after only you are going to apply the expansion. Otherwise, always we will have a mismatch with the final answer. Okay? So is it clear to all how to apply this methodology? Right? So I will give the final simplified answer. You can check on that. So it is given that yeah. I will revise the approach one more time. The same thing for the same problem. Okay? Right. So is that final answer is matching with your fine. So I will repeat right from the beginning. We have yp is equal to 1 by d cube plus 3d square plus 2d of x square. Now what happens whenever x square, x cube, this kind of function is there on the right hand side, we are going to make use of the expansions. Those expansions must be of the form 1 plus or minus something in the denominator. So to have that, I have taken d as common so that constant will be free. So by taking the constant as common, I will get the required expression 1 plus or minus something in the denominator. So if you take 2 as common here, 1 plus d square plus 3d by 2 of x square will come. This whole thing is treated as 1 plus x in the denominator. So 1 plus x whole power minus 1 of x square is the form. Accepted? If that is clear, then I move further. That is also correct. The only thing is, how did you take the common? That is the only thing there with you. Simplification varies from person to person. Please understand. So that is why in majority of the cases, we stick on to the approach, not with the answer, especially x power n case is given. Now what happens here? If you apply the expansion 1 minus x plus x square plus so on other terms. If you are interested, you can calculate x cube also there with your own interest. I can say one more thing. If you apply x cube so that d square plus 3d by 2 whole cube will come. So even though if you apply that, since 1 by d is there, you will have a constant at the end. Accepted? So that you can apply one more term in the expansion. It is possible. Yes or no? You apply a plus b whole cube. Right? Let me say d cube, d square whole cube plus 3d whole cube plus 3 into d square whole square into 3d plus 3 into d square into 3d whole square. So are you going to get any other term after dividing with d square or something in that expansion? Is it possible there or not? Yes or no? Are you getting me or not? So no term will come. Accepted? If you apply x cube formula there included in that expansion. So if at all, by taking the common, if I take d square here, so is it possible or is it necessary to go for one more word or one more term in this expansion? If it is there, I will give you a very simple example. One by d power, I think it is not visible there. Yeah. If you take 1 by d power 4 plus d square of x square, right? What is the term you are going to take common here first? D square. Accepted? So 1 by d square into 1 by 1 plus d square of x square. It will come the category as 1 plus d square whole power minus 1 of x square. Accepted? So what happens while applying the expansion here? Since d square is presented, you are going to calculate one or two more terms in this expansion. So actually what happens? 1 by d square into 1 plus x whole power minus 1, 1 minus x plus x square right. So depending upon the power of d here, sometimes it is necessary for you to calculate one more term here in this expansion. That is my intention actually to say, right? Fine. So coming to this problem, by applying the expansion here, 1 minus x plus x square. So 2 square is 4, x square, d power 4 plus 9d square plus 2ab means 6d cube. Other terms are neglected here of x square. So if we apply with d here, so it is nothing but 1 by 2 into 1 by d minus d plus 3 by 2 plus here d cube plus 9d plus 6d square by 4. So here d cube is neglected because it contains more power than x. These two will be considered. So on simplifying, you will get this final answer. So you check on that after applying the function to each term. So 1 by d means integration. So integration of x square is x cube by 3. So differentiation is 2x plus 3x square by 2. Then you have to apply 18x plus 12 by 4. So on simplifying, you are going to get that answer. Please check. Accepted. Yeah. That is why I mentioned whenever x square, x cube things are given, then obviously you will have a mismatch always with the constant. Always with the constant. Right. See, since 1 by d is there, I have multiplied with d, so 6d square will come there. Because we have 1 by d is there, this 1 by d is applicable to each and every term of it here. So 1 into 1 by 2, 1 by d, this value into 1 by d, this value into 1 by d. Accepted. So we have to consider 6d square 2 to get the exact value. Otherwise, you just have to stop this part. To have the complete solution, you need to consider 6d square 2, because if you apply 6d square for x square, you will get a number. You will have a value, because the power of d is equivalent to the power of x. X cube in the above equation. So that's why what I am saying. So if you consider the x cube, then also you will have a term. That's what I am mentioning always. So obviously, this problem is based on time consumption. So usually we apply 2 or 3 terms in the expansion, then we stop. So you can apply up to this and this. So if the same question is given for 10 marks in the exam, I am going to apply the formula up to this part. So later, I will write the other terms. Other terms I will quote in the bracket and I will leave the problem. I don't want to consider them. I don't want to write them. Exactly. Depends upon weightage. Because let me say, under compulsory part, section A, first question, you will have to answer 5 things or 4 things usually, right? Each carries 10 marks weightage. So the success or the score will come always based on the first question. Accepted? So section A, first question, section B, first question, the compulsory part. If you have done all the 5 parts correctly, 100 will be your score at the least. So depending upon your favorite topics, automatically you will reach 200. Accepted now? So that's why if the same question is given for 10 marks, I am going to do in this manner. I will write that terms having other powers equal and more than x square. You will write that and do with this part. Stick on to this part only. So at the worst or at the most, you will get 8 marks if the 10 is not awarded to you, because they cannot condemn the procedure. Accepted? Fine. So is this approach clear to all now? Whenever x square, x cube is there, how to solve? Right. So let me take the other model. So the third model here is, whenever the RHS Q is of the form e power ax into something. So usually, what is the possibility for us for Q in this context is e power ax into sin x, e power ax into cos x, or e power ax into x cube, x square, like that. So these are the usual things commonly we do while calculating YP. So for that, I will describe the procedure by taking a problem. So doing problem is more efficient than explaining for this concept. So please note down the problem. So solve d square minus 6d plus 13 into y. So please take a note of this, then tell. So please calculate YC first on your own, then inform, because it will become an automatic practice for you for every problem. just mention the roots to me. YC roots. So 3 plus or minus 2i. Right. So YC is nothing but e power 3x into C1 cos 2x plus C2 sin 2x. So any queries for anybody with regard to YC? So for YP, 1 by d square minus 6d plus 13 into 8 e power 3x into sin 2x. So whenever this thing is there, always remember that this exponential part should be taken to the front. And this will remain here. So in the denominator, the differential d is replaced with d plus the power. So d plus 3 whole square minus 6 into d plus 3 plus 13. Are you getting the ideology? What I have done? So this is fixed. Whether the power is positive, negative, whatever it is, the exponential part should be taken to the front. D is replaced with d plus the power, and you are going to do the remaining procedure with the other function presented there, whether it is sine, cos, or arithmetic function. So can you simplify this part? What it will be in the denominator? So d square plus 4 into sine 2x. Now you totally forget about this thing. You just concentrate on this part. So whenever sine or cos functions are there, what is to be taken? D square should be replaced with minus the number whole square. If denominator gets undefined, we have the formula. So you are going to write the formula there. So this is 8 e power 3x into minus x by 2 into 2 cos 2x. Please check on the answer for YP. Clear? Then we write the general solution, y is equal to yc plus yp. So the only thing e power ax into something is presented, always we bring exponential part to the front. D is replaced with d plus the power. Fine. And for the rest of the things, we apply the previous methods what we have discussed. Sine, cos, x square, whatever the thing is there, we apply that methodology here. Now here I will take one typical problem which gives you a complete idea of the three models we have discussed so far. So can I take now? Later we wind up our discussion on the three models discussed. Right. So please note down that d square minus 4d plus 3 into y equal to 2x e power 3x plus 3 into e power x cos 2x. So that is the problem. So straight away I will start with yp. So we are going to evaluate the two things individually for better understanding. Shall I proceed? So I will write the solution one after other. You cross check me if I go wrong anywhere. Please check and you can ask your queries. Please check on that. If any queries you can ask, then I go to the other part. I have evaluated the function only for the first one. Any doubts for anybody for the first part? Please say. So can I take the second one then? Please take a note of that. After noting, please inform. If any doubts with regard to approach, you can ask. If any step is confusion, highest power is 1, right? Since actually we do at that part, let me say the clarity over this thing. Suppose at this part if you have done like this, since highest power is 1, you are saying that just to do like this, then do the integration after having the simplification part here. Accepted? Yeah. Since d is there, 1 by d, you will have the integration thing there. So you can have the chance of getting one more term inside. That's why we are doing this. So This is the answer. Please check. Accepted? Yeah. Now, if you consider one more term in the expansion, you are getting the constant here. Please check. Up to constant, the same answer will come. Only you have a mismatch with the constant. Agreed? Yeah. That is why I am saying that always we have like chances of getting a mismatch with the constant in simplification, unless you do it correctly. So the fundamental procedure we follow is, whenever 1 by d is there, try to calculate one more term in the expansion, even though the power is 1 or 2, then multiply with 1 by d, then do the thing. Yes, the answer will change automatically. That's what I am saying. So the standard procedure is that you calculate one more thing, apply 1 by d, then only you simplify. So don't do the simplification first, then integration. So first simplify, first integrate the thing, then simplify. In the simplest manner I will write. Do simplifying with 1 by d first, then apply expansion. Okay? Clear now? So that you have always like chance of getting a constant or other term in the expansion. We need not take d square coefficient. That means you are asking a problem with d square in the denominator, x power is 1. I agree with you. Since x has power 1, there is no need to take d square. If 1 by d is not presented before, there is no need to consider d square. Since 1 by d is there, we are considering d square. That's it. So I will go with the other thing. So for this part, take the exponential to the front. So 3 e power x by 1 by d plus 1 whole square minus 4 into d plus 1 plus 3 of cos 2x. So if we simplify that, 3 into e power x by, can you give me the value here? On simplifying, so it is d square minus 2d into cos 2x. So whenever d square is there, we should replace with minus b square. So 3 e power x into 1 by minus 4 minus 2d of cos 2x. You can take common minus also. 2 you can take common. So d plus 2 cos 2x. You can rationalize this. So applying this, you have minus 8 here. Am I correct in getting the thing? Fine. That is the final answer. Accepted. So the three methods what we have discussed so far, in today's session are most important in majority of the cases. So there is one more model is there. In the next session, we are going to discuss. Then the higher order differential equations is totally completed. So we are left with Cauchy-Euler equation, variation of parameters, and the reduction method. So on Saturday's session, we are going to discuss one after the other. So mostly I am going to finish it by Tuesday. This part, complete higher order differential equations. Fine. So let me give a simple idea that if I have given a problem that f of d into y is equal to 8 into x square plus e power 2x plus sine 2x. Now tell me what you are going to do for that problem. Yeah. So 1 by f of d into 8x square plus 1 by f of d into e power 2x plus 1 by f of d into 8 sine 2x. So you are going to apply the three methodologies individually for the function. So the complexity in the problem is given by the question which is given here and the question which I have discussed now. So the usual complexity for 15 marks question will be like this. So you need to apply 2 or more methodologies for a single problem. Okay? That's it. Mostly I am going to give a practice session for you on the models which we have discussed it for today, provided with the key. And no. On Saturday, I am going to finish with variation of parameters method. Monday, higher order differential equations with variable coefficients. Since the coefficients are only numbers here, we have calculated YC very easily. If the coefficients contains functions, how to calculate YC and how to calculate YP. And on Tuesday, I will discuss about the reduction method. There the total ODE will be completed with regard to higher order equations. And the only part left is Laplace transforms. Fine. That is the ideology. So usually we can expect one question on variation of parameters. The drawback with variation of parameters is it is applicable for only second order equations. For third and higher order equations, it is not applicable. It takes more time. So variation of parameters is asked only for second order differential equations. That is only d square is presented. For d cube, d power 4, we won't use that method. And it is very convenient and easy to solve any kind of problem using variation of parameters under second order. Okay? Thank you. So let us stop our discussion today here and we will meet on Saturday. Thanks to all.